Now in our third chapter, circle of geometry, I will learn circles passing through 1, 2, 3 points. Now first we will see how many circles pass through one point. So here, suppose this is point A, and from this point A, we will study how many circles can be drawn. I will take another point Q or P. Suppose I will take P as a center, and taking P as a center and taking PA as a radius, I will draw a circle here. Now P is the center. Okay. And draw a circle passing through point P. Okay, in this way you can draw a circle here like this. Okay, now I will take another point Q here and take Q as a center, and QA is equal to radius, and I will draw a circle. In this way, using QA as a center, you can draw this circle. Now you can take another point as R and take AR as a center, AR as a radius, and R as a center, and you can draw another circle. Okay, in this way, from point A, you can draw infinite circles. That means from one point you can draw, that means infinite circles can be drawn passing through one point. That means infinite circles pass through one point. Now we'll see how many circles will pass through two distinct points. So here AB, these are the two distinct points. Now we will draw circles which pass through points A and B. Now we will see how many circles we can draw. For that, we will draw a perpendicular bisector of this. Now this is a perpendicular bisector, this is the midpoint. Now you take any point on this bisector and any point as a center on the bisector and draw circle with radius. Okay. Now you can draw this circle. Okay. So you can take another point here Suppose this point is P, this point is Q. Now first time we have taken AP radius. Now take AQ radius. Okay. Then again try to draw circle. In this way, as many points you take here on this bisector, that much circles we can draw. That means we can draw infinite circles passing through two distinct points. You take any points here like that as a center, and you can draw infinite circles passing through points A and B. Now three points which are non-collinear. Suppose these are the 3 points, point A, B, C. These are non-collinear points. How many circles can we draw passing through these 3 points? Already we know that if you join these points, we get a triangle. Okay, and we can draw a circumcircle on this triangle which pass through point A, B and C. And already we know that construction. We can draw a perpendicular bisector of any two sides. That bisectors will meet, intersect in one point. Take that point as a center and take a radius up to vertex and draw a circle. We can draw only one circle. That means we can draw only one circle passing through 3 non-collinear points. Now if the points are linear, points are collinear, can you draw a circle passing through these 3 points? Obviously no, we cannot draw a circle passing through 3 collinear points. That is why now here we have these important points here. First, infinite circles pass through one point. Infinite circles pass through two distinct points. There is a unique circle passing through 3 non-collinear points. No circle can pass through 3 collinear points. Now next we learn a secant and tangent. Now see here, in the plane, 3 circles and 3 lines are given here. In first, a circle with center A, and this line here. Okay, now in second figure, circle suppose is center P and and B, and line which intersect the circle in point P. This is line here. And in third figure, a circle with center C. And line N which intersect the circle in two distinct points. This is first figure, second, now here. In first figure, circle with center A and line L. Both do not have any common point. That means they do not intersect each other. Now in second figure, a circle with center B and a line M. Now here this line M touches the circle in point P. That means this line L intersects the circle in one point. And in third figure, with center, a circle with center C and line N. This line N intersects the circle in two distinct points. That means this line L intersects the circle in point Q and R. Now here, in second figure, this line here is called a tangent of the circle. Tangent, that means a line which touches the circle in one point. Or the line in the plane of the circle which intersects the circle in only one point, that line is called a tangent. And a line which intersects the circle in two distinct points, that line is called the secant. Now here line N is the secant of the circle and line M is the tangent of the circle. Now we will learn the properties of tangent of the circle. Before that, we will have one activity here. We will learn that activity. Now see here, in the figure, a circle is there, center of the circle is O, and these are line AB, intersect the circle in points A and B. This line AB is perpendicular radius OP. OP is the radius of the circle. And line AB is perpendicular to radius. Now, now see here, this line slides towards point P. Okay. As this line slides towards point P, like this, these points A and B approach each other along the circle. These points A and B approach each other. When the line is here, points A and B are here. When line is here, points A and B are here. When line is here, points A and B are here. Okay. In this way, as this line slides, points A and B approach to point P. At the end, these 2 points get immersed in point P. But the angle between radius and line remains same. That means right angle. So here, in this way, now this line which makes right angle to the radius, this line is tangent to the circle. Points A and B approach each other along the circle. At the end, they get merged in point P. But the angle between the radius OP and line AB will remain a right angle. At this stage, the line AB becomes a tangent of the circle at P. Tangent of the circle at P. And this stage, that means this stage, this line touches the circle in point P and it is perpendicular to the radius. And this line is called tangent to the circle. So it is clear that tangent at any point of a circle is perpendicular to the radius at that point. And this property is known as tangent theorem. This property, tangent theorem. Now, in next period, we will prove this tangent theorem. That means a tangent at any point of a circle is perpendicular to the radius at the point of contact.